Okay, everyone. So we're gonna get started now. As more people come in, they'll probably just be led into the meeting, but we'll get started with today's activity. Before we get started, a quick land acknowledgement. We acknowledge that Western University is located on the traditional lands of the Anishinaabe, Haudenosaunee, Lenapehoak, and the Attawadaron peoples, on lands connected with the London Township and Sombre's treaties of 1796 and the District Wanspoon Covenant Wampum. This land continues to be home to diverse Indigenous peoples whom we recognize as contemporary stewards of the land and vital contributors of our society. Now I'm going to start sharing my screen and we'll get started with today's workshop. So welcome to Western Engineering Outreach. My name is Dami. I will be your host today. I will be assisted by Ganesh. Ganesh also works here at Western Engineering Outreach. I am the outreach programs coordinator here, which means I'm in charge of organizing and developing curriculum for different fun STEM workshops. And today, our STEM activity is called MicroBit Rock, Paper, Scissors. So for today's workshop, I expect that we all be respectful. I'm gonna ask that you keep your mics muted to avoid background noise unless you have a question. If you have any questions, please feel free to ask either me or Ganesh. Now, during the activity, I may not see your chats because I am sharing my screen. So if I do not respond to your questions, you can always ask Ganesh. He will be the second instructor for today's workshop. To ask me a question, you can use the Zoom chat function. You can use the Zoom chat to send me a direct message or send Ganesh a direct message. There's also the Zoom reactions button. Now, if we all look at the bottom of our screen, we'll see a smiley face and it has a bunch of Zoom reactions. If we could test that out, could everybody send me a thumbs up? Thank you. That's great. Looks like everyone's working. Now you can use the Zoom reactions to let me know if everything's going fine with the workshop. And if you want me to slow down, you can always just send me a message. And most importantly, I want everybody to have fun today. For today's workshop, all you're going to need is a device with an internet connection and access to the MicroBit website. I will be sending you guys the link when we begin our activity, so you don't need to bother memorizing this. And if you're on the Zoom call, you're already on a device with an internet connection. So today we're going to be learning about software engineering. We're going to be learning about coding. But firstly, here's a short video explaining what software engineering is.
Next, we have software engineering. And software engineering goes hand in hand with that computer hardware part. If the hardware doesn't work with the software, then the computer won't work at all. So software is actually the coding that's inside all of the apps and the different programs, the websites that you're using, the videos that you're watching. And that coding is the set of instructions that we're giving to our computers. Next, we
So like the video said, a software engineer works with the software on a computer. And software is what works with the hardware on a computer. The software is built using code. Now, for all of our engineering workshops, we like to highlight an engineering hero. And today's engineering hero is Dr. Grace Hopper. She was born in 1906 and she died in 1992. She was an American computer scientist and a US Navy Rear Admiral. She helped build one of the earliest computers called the Harvard Mark I. She also made the very first English-like coding language, and that language was called COBOL. Before COBOL, all computer programs were written in binary. And binary is a combination of zeros and ones that stands for off and on. This binary on your screen says hi. The Harvard Mark I was one of the very first computers built during the end of World War II. It weighed over 9,000 pounds and it used hundreds of miles of wire. It was 51 feet by 8 feet by 2 feet. It required a whole room just to fit this computer in it. It started working for the United States in 1944. It was able to do 3 additions and subtractions in 1 second, and it could multiply in 6 seconds and divide in 15 seconds. Now, in the 1940s, this was the peak of computer engineering. But today, you can do much more complicated calculations with a device that can fit in the palm of your hands. Now, coding, also called programming, is the set of instructions that you give to a computer. It's what you give to your computer to make it do what you want it to do. There are lots of different coding languages, but they all work very similarly. Most coding languages work sequentially, which means your instructions have to go one after the other, and your computer will only perform your instructions one after the other. Can anybody tell me any programming languages they've heard of? I want you guys to type in any programming languages you've heard of in the chat. So Reho says JavaScript, Python, Java. Ruby said C++, Python, Block. So I see we have a lot of programmers here with us today, which is great. These are all very good examples of programming languages. HTML, C#, wow, you guys know everything. That's good. So some examples of programming languages are C++, like you guys have named, Python, JavaScript, C, C#, Java, Block, and there's many more. The reason we have so many different types of programming languages is because they're all made to do different things. So languages like JavaScript are very suited to make websites. JavaScript is a language that people use to design websites. HTML is also a language that's used to design websites. Languages like Java, on the other hand, are very useful for designing applications. So for things like video games and Snapchat, languages like Java, C++, and C are very useful for designing them. Block, however, is a very basic language. It's based on JavaScript, and it helps people learn programming easily. It's a very good introductory language, and it's the language we're going to be using today. We are going to be learning how to code on a MicroBit. A MicroBit is a microprocessor. MicroBits can perform very cool electronic projects. Block coding is a great way to learn how code works. You don't have to learn all the grammar and syntax rules that comes along with other coding languages. Now, here are some of the blocks that we'll be using today. This is the basic block, and this is where you find the most basic commands. Some of them are the onStart command. Your MicroBit will read whatever code is inside your onStart block whenever it starts. Then we have the show number block. Your MicroBit will make whatever number is inside your show number block appear on its LEDs whenever it sees the show number block. Then we have the show LED blocks. If you place a show LED block onto your MicroBit worksheet, your MicroBit will turn on whatever LEDs that you select. Or you can also use one of the pre-made designs that the MicroBit has, thanks to the show icon block. Next, we have the show string block. The show string block will tell the microbit to display text. Texts in computer languages are called strings. So things like names of schools, names of people, anything written with letters is called a string. And if you want your microbit to display a string, you do it using the show string block. Another basic command is the forever block. Now your microbit will make whatever code is inside here repeat forever. Then next we have input commands. Input commands are communication commands, and these is how we communicate with our microbit. We have the on button A press block. The on button A press block tells your microbit to initiate a certain code whenever that button is pressed. You can change button A press to button B or button A plus B. There's the on shake block. Now you can also make your microbit do something when you shake it. To make your microbit do something if you shake it, you use the on shake block. And your microbit will initiate code whenever you shake it. Now, as we go through the activity today, it will help you to split your screen so that you can see what you're coding and you can see the Zoom window at the same time. Now let's get on to the website. Today, we're going to be using MicroBit Classroom, and MicroBit Classroom helps me to be able to see you guys' code while you're working on it. And if you have any questions, I'll be able to look at it. It also allows Ganesh to see your code while you're working on it. So Ganesh will be able to help you if you ask him any questions. To join the MicroBit Classroom, I need everyone to go to the URL on the screen, microbit.org/join. I'll also put the URL in the chat. And once you click that link, it'll ask you for a classroom name and a pin. It'll ask you to list out a color, an animal, an object, and a mode of transportation. So the color will be green, the animal will be dog, the object will be guitar, and the mode of transportation will be fire engine. And the pin is 958866. So I see Ganesh is joined in, which is great.
What's the pin again?
It's 958866. It's on the screen. You guys still see the screen?
How do I see your screen?
See my screen?
Yeah, like, do you have like a screen showing?
I do, unless you guys don't see it anymore. You see it now?
No.
You, you don't see this screen with the URL, name, and pin?
We see that.
You see that?
No, I don't see it.
Try click. Are you at like the place where you can see everybody?
Yeah.
So can you see? Maybe if you look.
I think you might have Zoom minimized, so you might have to split your screen.
Maybe open up Zoom.
Yeah.
Like, so your whole computer is filled. And then you should probably see it, because if you minimize it too small, it's not gonna show the screen because
Yeah.
Okay, I see it now.
Ah, great. So we're just I think, is this everyone? I think we're waiting for one more student. Because since Ganesh is in here, I should see 16. There we go. All right, we are ready now. So once you're logged in, you should see your editor, and your editor should look like this. So you should all have the OnStart block. If you don't have the OnStart block, that's fine, but you should see your worksheet here where you can put blocks. And then you have your MicroBit. This is a simulated MicroBit on the left-hand side of your screen. You can use the stop button to stop the simulator and the play button to play the simulator. Just leave the simulator playing. There's no need to stop it. We'll be coding in blocks, so you don't need to switch it to JavaScript. And on the left-hand side of your screen with the menu is where you find all of the different types of commands. Now, today we're going to be trying to code a rock, paper, scissors game. And when you play rock, paper, scissors, the first thing you do is you shake your hands and then you display rock, paper, or scissors. So we're going to need a different input than on start. So the first thing we do is delete the on start block. And you can do this by right clicking it and clicking delete block. Or you can also drag your block to the left-hand menu. Next, go to input commands and add the on shake block. Once you do that, you'll see a shake button appear on your MicroBit. You can click it to send a shake command to your MicroBit, or you can move your mouse on the microbit, which will cause it to simulate a shake. Now, let's first of all test to see if our microbit's actually receiving this command. So to test it, let's use the LEDs on our microbits. So go to Basic and select Show LEDs. Drag the Show LED block and place it inside the On-Shake block. And now select all the LEDs. To do that, just click on each LED and it'll light up. Now to test out the Show LED blocks, just click on Shake. And you see all the LEDs on your microbit light up. So now you know your microbit receives the shake command. Yep, when I shake it, it lights up too. Nice.
Oh, hi. Sorry, a quick question. Can you do this on a tablet too? Because we're working on a tablet, but it's not activating the same way.
I think you can do it on a tablet. You should be able to. So what exactly is the issue? So you're on here signed in as Deborah, right?
Actually, Mary.
Oh, Mary? Okay. So let's see. Mary. Let's take a look at your code. Okay, so the code looks fine. Do you have your microbit next, like the microbit simulator next to you?
Yeah.
Yeah.
And is there a shake button there?
Yeah.
And if you press the shake button, the LEDs don't light up?
Oh, it does.
Oh, okay.
There you go. That's it.
Thanks.
No problem. And I'm not sure if you can do this on a tablet, but I know on a computer, if I just move my cursor on the microbit, it shakes. So you can try moving your hand on the microbit to see if it shakes too. Okay. So next step after our onShake command is set up is creating a variable. So go to variables and type in hand. The variable is what you will be manipulating today. If you've made your variable, can you send me a thumbs up using the Zoom reactions button? Okay, sounds good. Next, we will go to variables and select the set hand to 0 block and place it underneath show LEDs. And then go to math and select the pick random 0 to 10 block and place it at the 0 portion of your set hand block. Now, if you look at your code, you'll see that after you shake your microbit, it'll turn on your LEDs and it will set the hand variable to pick between a random number from 0 to 10. So your hand variable will pick between 0 and 10, and it'll assign that number to hand. Now, when you're playing rock, paper, scissors, there are only 3 options: rock, paper, or scissors. So we don't need your hand to choose between 11 options. We only need 3. So instead of 0 to 10, let's change this to 0 to 2. So hand will either be 0, 1, or 2. Now, so far, hand is just a number, but we want an actual image. So we need an if statement and make its parameters, we'll make its parameters image equal 0, and then we'll insert a show icon block that'll help us display an image for whatever number we have. And I'll explain how to do that. First, let's go get an if statement from logic and grab the if then else block and place the if then else block right underneath the set hand block. Now we need a condition. So go to logic and scroll down to these comparison blocks and select the 0 equal to 0 block and place it where it says true on the if then else block. Make sure when you're dropping your blocks, what you want your block to stay in is highlighted. So whatever you want it to be in will be highlighted. So true, there we go. So now, next we go to variables and select hand and place it at the first 0. Make sure only the first 0 is highlighted, not the whole comparison block. So now our MicroBit will check if hand is equal to 0, and we want it to display something whenever hand is equal to 0. So go to basic, select the show icon block, and place that underneath the if block. Now change this icon from a heart to a small square to symbolize rock. And now whenever hand is equal to 0, your MicroBit will show the icon for rock. If you have your hand equal to 0 condition set up, send a thumbs up using the Zoom reactions button. Nice. Okay, next we'll be setting up our conditions for paper and scissors. So click the plus button at the bottom of the if then else block. And we have a second if. Then go to logic, select a comparison block, place it at the blank hexagon. Go to variables, select hand, and place it at the first 0. And this time, make it if hand equal 1. Next, go to basic, select show icon, and place it underneath the else if. And let's change this icon to a big square for paper. So now hand equal to 1, you show icon, big square for paper. So if we have hand equal to 1 set up as well, send me a thumbs up using the Zoom reactions button. Nice, nice, nice. Great job. Smart kids. Now, question for everybody. We've set up our MicroBit to show small square when hand equal to 0 and a big square when hand equal to 1, which is rock and paper. What are we going to do for scissors? How do you guys think we should tell our MicroBit to show scissors? Any ideas?
The same thing, it's just that hand, the comparison thing, hand is equal to 2.
That's good. That's very good. Very smart, Rishar. And yes, making a hand equal to 2 is a very smart way to show scissors. But I'm going to show you guys a trick. Now, since we have the else block there already, and we only have 3 options, either 0, 1, or 2, there's no need to create a second comparison. We can just go to basic and grab show icon and place it in the else block and change this to scissors. Now, can anyone tell me why that works?
Because else is like the final one.
Yes, that's correct. Else is the final one. So if hand isn't 0 or 1, it's going to be whatever is in else. Nada also says else show icon because there are no other options. That's correct. Thanks, Nada. So with that, your MicroBit code is complete for rock, paper, scissors. And if we click shake, you have scissors or scissors. MicroBit keeps playing scissors. Oh, now play paper. Back to scissors, back to paper. And you can play rock, paper, scissors against the MicroBit if you want. Now, before you start, just a quick question for everybody. If I change this number from 2 to 7, what icon do you think will show up the most? Wait, hold on. I think Mary had her hand up. Sorry, Gosha.
Maybe the number 2.
Yes, the last one, the scissors. Scissors will show up the most because anytime it's 2, 3, 4, 5, 6, or 7, your MicroBit will set it to scissors. So yeah, scissors should pop up more than every other one, which is what's happening. There we go. That's a good way to cheat your MicroBit into beating it. So now you can play rock, paper, scissors against your MicroBits. So if I wanted to play against my MicroBit, I would go rock, paper, scissors, shake. Oh, I lost. Tough. Rock, paper, scissors, shake. I won. So we finished our rock, paper, scissors game. Now you guys can play against it if you want, or you can play against other people's MicroBits if you want. That'd be kind of fun. But we now have a problem. We're playing rock, paper, scissors, and we have no way to know if we win or lose. So I want to know if I win or if I lose. I like to keep score. I'm a little competitive. So I'm going to use the inputs on our MicroBit to do that. So here's our first challenge of today. So if we go into input, grab the on button A pressed. So on button A pressed. Place it in. Now your MicroBit will do something anytime you click button A because of this block. To change what button you want to manipulate, you can change it by selecting A, and you can click either A, B, or A plus B, which is the third button on your MicroBit. But for now, we're just using button A. Now, if we win, we need a way to keep score. So firstly, we need a new variable. So go to variables and change this variable to my score. If you have the new variable set up, send me a thumbs up. Nice. Now go to the change my score by 1 block in variables and place it inside the on button A press block. So now whenever you press button A, your score will go up by 1. And to let the person know they won, go into basic and select show string. And change this string to win. We want to see our score as well. So go to basic and select show number and place that underneath show string. So this is show number 0. So it'll only show the number 0, but we wanted to display our score. So go to variables, select my score, and place it at 0. So now whenever button A is pressed, it'll change your score by +1, +1. It'll show the string win, and then it'll show your score. So if I play a game, rock, paper, scissors, oh, I lost. Rock, paper, scissors. I lost again. Rock, paper, scissors. Rock, paper, scissors. Okay, I won. So if I win, I press button A, and it says win, and then it shows my score, 1. That's pretty, I feel like that display is kind of lame. So let's kind of try to make that display a little bit cool. Let's make it look, let's make one flash across our screen whenever we win. So to do that, we need a loop. So go to loops and select the repeat 4 times block. Place it right underneath show string. Next, grab the show number block and place it inside repeat 4 times. Next, go to basic and select show LEDs and place this underneath show number, but leave it blank. And go back to basic and grab a pause block at the bottom of basic commands. You see pause, and place this in between show number and show LEDs. And let's make this repeat 3 times. So what's going to happen is whenever you press button A, your score goes up by 1. Your MicroBit will tell you you win, and then it'll show your score, pause, and then turn off the LED, and then do that 3 times, which will make your score flash. So it'll show it, turn it off, show it, turn it off, show it, turn it off. So let's test it out. Button A, so win. And then 1, 2, 3. If I press it again, my score should go up by 1. So now it should say 2. 1, 2, 3. That's pretty cool. So if you have your winning code set up, send me a thumbs up. Oh, hi, Reho. Is it Reho or Rejo? I'm not sure. Or is it Reho? The second one, Rejo? Ah, hi, Rejo. So now you guys have successfully tracked your number, displayed your number of wins on a BBC MicroBit, but we have no way to track and display our losses. So now here's a challenge for you guys for the next 5 minutes. See if you can figure out how to code a loss on your MicroBit. So go.
When we're doing the loss thing, is it supposed to be like minus a point or the point stays the same?
I would say minus a point. So yeah, so if the person loses, you want to drop their points. If you win, your points go up. If you lose, your points go down. Let's make it a penalty. Great question, Grisha. If you figure it out, just raise your hand using the Zoom raise hands function, and I'll go look at your code to see if you got it right. And so don't tell anybody else what you got. If you figure it out, just use the raise hand function, and then I'll go look at your code to see if you got it right. Priyash just raised his hand, so I'm going to go look at his code. Oh, Netta also says she's got it. So Priyash, you actually got it right. This looks really good. Except I think you're going to show your score too many times. I think you don't have, like, you see how my code looks like? You don't have to show your score before the loop. So I would remove the show score before the loop, but that looks great, Priyesh. Let me see, Netta. Let me go take a look at Netta's. See if Netta got it right. Netta said, oof. If person loses, oof. But that's really good, Netta. That's correct too. You got it right too. Let's go see Rajo. Rajo, yours is correct as well. Great job, guys. Oh, Mary is also done. Let me go see. Great job, Mary. You got it right too. That looks great. Oh, wait. Actually, Mary, there's one thing I think you need to change. So when you win, you change score by 1, but when you lose, you want the score to go down.
I'm done.
Oh, was that Gersha? I'll look at your code too.
That was Liam.
Oh, that was Liam? I got you, Liam.
All right.
So Mary, for when you lose, you gotta change your score by a different number. There you go. Good job. And Liam, that was correct too. Good job, guys. Okay, great job, guys. So I'm gonna do it now. So if you haven't finished it yet, this is how you do it. You just go on button. But instead of on button A pressed, you use a different button. Change your score by -1 and show a different string. I like that. There you go. That's it. And there's other stuff you can do as well. You can play music for when someone wins or loses, and you can change the melody that plays. So if someone wins, you can play like a melody. It's up to you guys. So that's pretty fun. Okay. Final challenge for you guys. So now we have a way for when to record a score, winning score and a losing score. Try to reset the score to 0. See if you can find a way to reset your score to 0. So if I press, well, I'm not going to press A because that's going to play a sound. If I press B, it'll say oof. and then it'll display -1 because I haven't won anything, but it'll stay as -1. So see if you can find a way to reset the person's score to 0. Rachel, is your hand still up for a question, or is that just from before? It's from before. So final challenge, see if you guys can figure out how to reset your score to 0. While you guys are doing that, I'm gonna play around with this melody thing. Netta says she thinks she did it. Oh, okay. Let me go see. On so part of the code is correct. Just your input, I would choose a different input. Now there's a third button, guys, just as a hint. There's a third button on your microbit. It's called A plus B. So you can use on button A plus B. It's just a hint for everybody. So if you go, so I'll show you guys. Resume share. If you go to input and grab on button A pressed, you can change this to A plus B. And a button will appear on your microbit that says A plus B. So very big hint for everybody. So you can use that button. Rajo said he did it. Gersha says he also did it. Okay, let's go see. Let's go see what we... Gersha, did you get it right? So Gersha, your code will currently leave your score the same. That will not change your score back to 0, but close. But that'll just leave your score the same. And you don't want to do that. You want to reset the score to 0. So tough. That's not it. Sorry, Gersha. Let's see what Rajo did. Oh, now that's a question. If you put it on your actual microbit, how would the shake work? Also, microbits have gyrometers on them. So if you shake it, it can actually sense it. So you can actually shake your microbit and it'll do something. If you have an actual microbit, if you just shake it, it'll do it. It'll execute your code. Yeah, it's pretty cool. It's a really cool workshop if we had actual microbits with us.
We're done.
Okay, hold on. I gotta look at Rajo's first.
All right.
So Rajo, also, that's not it. That's not it either. Close though, but that's not it. Let me see if Liam got it. So Liam, that's actually correct. Now the only thing you didn't show your score. So you've reset it. You need to display your score as well on the microbit. But
Okay.
you've gotten the first part right.
Okay.
Let me give everybody a few more minutes, and barely like 2 more minutes to see if they can figure it out. So big hint, on button A plus B pressed. Very big hint. So Rayo says he thinks he fixed it. Let's see. Let's see, Rayo. Okay, you got it. But you got to show the score too. So you've got it. That's how you do it. So I'm just going to show everybody. Gersha says he also thinks he fixed his. Let me see. Yeah, that looks great. So this is how you do it, guys.
I just did it.
I saw Liam. You did good. That's really good. So to reset your score, after putting on button A plus B pressed, you simply go to variables and select set my score to 0. And that'll set your score to 0. But you want to show your score on your MicroBit. So go to basic and select show number. And this will show us a number. And go back to variables and change that number from 0 to my score. And finally, show string and change this string to reset. Just so the person knows the score is reset. And you're done. That's how you reset your score. So if I press A plus B, it'll show me 0 and reset. Or I guess I can make it reset then 0. That's all for our MicroBit rock, paper, scissors workshop. There's a bunch of other cool stuff you can do to your game. You can make it play music for whenever someone wins, like a different song for winning and a different song for losing. So that's a pretty cool way to play around with your rock, paper, scissors game. But that is all I have for you guys today. I hope you guys had fun, and we would love to see what you guys made today. So if you want, you can share your final product with us at discover@uwo.ca by emailing us, or you can tag us on social media at Western UEng. That's our Instagram, Twitter, and our Facebook. Now, if you scan the QR code on your screens, it'll give you the link to a survey. Now, that's a survey that I hope you guys help us fill out, just to let me know how you enjoyed today's workshop. And I've also included the survey in the chat. So thank you, everybody, for joining us today. I hope you had fun, and I hope you learned a lot.